Hi, my name is Bushy van Eck and welcome to another one of my videos explaining my theory. In the previous video we were talking about consciousness being perceived as a moment from the macro to the micro, and I also said that I would explain the importance of brain size. We also looked at the importance of a magnifying glass. The smaller magnifying glass, the less substance you will be able to visualize, and the bigger the magnifying glass becomes, the further you can see into the universe, like with the Hubble telescope. So let's just quickly recap on where we were looking at the duration of the universe, for example, or time at the different levels, at the Planck level, at the level of the universe with humans being somewhere in between, and we've also covered that the duration of a human's moment of awareness is approximately 12 seconds from becoming a memory and where it actually occurs. 6 seconds, which gives us 12 seconds. So there's actually much more to this than what we have covered so far by means of flicker fusion rates. But let's leave it at that for now. We'll cover flicker fusion rates just after this. If we look at the human mind, or rather brain size, let's start with a fly. A fly's brain, again, like I said, it's not about being scientifically correct, or even not even minutely. If I say a fly's brain's diameter is say 2 millimeters in diameter or circumference, it's not important. What's important to understand the logic behind it. So it doesn't matter whether it's 2 or 3 or 1 millimeter. What's important is that we understand the concept. Now if we get to a baby's brain, let's say the diameter of a baby's brain when a child is born is about 10 centimeters diameter. Again, not that important. When we get the adult's brain size, the brain of an adult is say 20 centimeters in diameter. So what we covered about a moment of consciousness, or 1 unit of consciousness, taking a certain time to travel around the circumference of a Planck distance, perceiving the speed of light to be extremely slow, where at the size of the universe, the speed of light would be perceived to be traveling at billions of kilometers per second during any duration. When we get to the level of the fly, which is within the scope of our perceived realities, the duration of a fly will most certainly not be over 12 seconds, but much smaller, somewhere in between here. So the speed of light to a fly, if we look at the diameter or a circumference, the speed of light to a fly is more or less 12 or 10 times slower than that of the human mind. So if a fly could see something passing by at the speed of light, it would be moving 12 times as slow as what the adult would see. With other words, to a fly, a human would be moving very slow. If a fly if I slot a fly at this speed, to a fly it will look like this. Very, very slow, coming in slow motion. If a fly could hear, and I swat it, then my voice would sound like this, being dragged out. If we could hear a fly, where a fly, if it could make a sound or had a voice which it has not, then it would be speed up. With other words, the way we perceive a fly, being so fast, is just the opposite for a fly perceiving ourselves to be very slow. That is where the unit of consciousness comes in. If we look at the Fibonacci sequence, or rather the magic number, the so-called number of 1.618 more or less, then every time you increase the circumference of the mind of a fly, then time would become twice as slow. If you add that circumference, multiply it once more with 1.618, it will become time to the perception of the fly would become faster, but looking down backwards, it's actually the other way around, becoming slower and other way around, becoming faster. So at the end of the day, a fly would perceive everything to be moving in slow motion, and from our level of consciousness being bigger, we would perceive everything at a lower level to be going much faster. Now, let's get to the size of a baby's brain. Why does it take approximately, let's call it 16 years, once a baby is born, takes about 16 years, more or less, for a child to fully develop, to fully accomplish brain size? There's a very valid reason for that. We can also ask ourselves, why in the animal world, if you look at horses, cattle, all these animals, why is it possible for a little calf to become a cow in virtually a year or two, having a growth rate which is much faster? But yet, for humans, being perceived to be much more advanced, why does it take ourselves being much smaller in mass, in volume, why does it take us much longer to develop full size? There's a very, very, very valid reason for that. The lower the intelligence level of a species, the faster the development from child to adulthood would be. The more advanced the species, the longer the duration. But why? The question now is why. If you look at a child, when a child is born, having a smaller brain size, speed within a child's mind is working much faster. His mind is working faster than that of an adult. Because his mind is working faster, everything around him is perceived to be moving slower. With other words, if you walk up to your child, to a baby, and you stretch out to pick him up, the way you see it, your hands moving like this, to a child it will be half as slow, moving like this. So now you can ask yourself, that why didn't you pick up when you were a baby? It's because your perception of time is gradually changing as you grow up. It's over a period of many years. There's no ways you can conceptualize that your mind is slowing down and your reality is increasing, and that time on the outside for an adult is becoming faster, where for a child it's slower. Now if you ask any child or any adult, and he will tell you that when he was a child, a holiday would seem to be lasting 2 or 3 times as long as it's lasting now. And that's exactly for this reason. A baby, during any one moment of time, has actually got twice as much time within his mind. So everything that you see is in slow motion. But why? Why does he got to see everything in slow motion? Because it's a learning process. If I had to teach you to do something, like for example, if you've never tied a shoelace before, and I had to show you how to tie a shoelace at a speed that I do it, you will tell me, slow down. Take it slow, slow down, I can't see what you're doing. The same with a baby. You don't need to show the baby slow down, because his mind has already slowed the perceived realities of time down. So all the lessons you teach a child is happening in slow motion for his mind to conceptualize it, to pick up on the lessons to be learned. So as he becomes more and more familiar with his environment and he learns more lessons, his time also speeds up, becoming faster and faster. That's why it will seem that the older we get, the faster time goes by. Now this is only valid up to a specific point, and then for other reasons it continues, but we won't go into the other reasons. We're here now to discuss the relevance of brain size. So this is why brain size is so important. The smaller the brain, the slower time on the outside will be perceived to be going. The bigger the brain, the faster everything else will be perceived to be going. If you look at the elephant, for example, having a much bigger brain, when I look at you walking, I'll see it at a normal pace. A baby will see it in slow motion. An elephant on the other side of the spectrum will see everything going very fast. That's why movements of people and that irritates elephants at times. That is why you will learn, if there's an elephant, they will tell you stand still, don't move, stand still, don't even move an arm or something. It's because every movement that you make is very fast. The same way we perceive a fly, almost in the same way an elephant will perceive us. We like flies to elephants. Not as much exaggerated if you look at brain size, but very similar. If you look at a dog, for example, having a smaller brains than humans, dogs tend to listen to sharp commands. If you tell your dog, sit down, it will ignore you. If you tell it sit, it will sit down. So all commands that you give to a dog in short, sharp voice, he will adhere to. Why? There's a very valid reason. A dog's brain is also smaller than a human's brain. So a dog will see a human moving slower, about 1.5 times. That is also can be worked out to exact details by knowing what to research. So if you move, you're actually moving 1.5 times slower in a mind's eye of a dog than what you perceive it to be. So all your voice commands as well. If you say sit down, then it will sound to a dog like sit down. That's very irritating. If you say sit, then it sounds normal to the dog like sit, because his mind processes information differently. Just this little thing I've told you now will eventually make sense of the visual spectrum. Why we can only see from 400 to 700 nanometers. If we look at a spectral, let me just erase this board quickly. If we look at the spectrum, humans can only perceive somewhere here from about 400 to 700 nanometers. But if we look at different brain size, when I'm talking about brain size, then there's a lot of things to consider. But for this exercise, we will talk as if the brain is one unit functioning as one unit. But there's different functions in a brain that do different things where time is involved. But for this exercise, we will now assume that humans can see from 400 to 700 nanometers. Now let's assume a normal person whose brain has developed 100% compared to other humans. Those persons 100% will all visualize the color spectrum from 400 to 700 nanometers. Their mind working at a specific speed. When we talked about a conscious moment at a Planck, at a conscious moment at a higher level, where humans are somewhere in between, consisting of a specific range of conscious moments. Now, if a human's mind differs slightly, if you have a person that is 2% off, if his mind differs 2% in volume or size or diameter or circumference, only by 2%, and you take the spectral scope of visibility and you change it with 2%, if his mind is 98%, if we look at a human with 98%, then we can subtract 2% from the 400 to the 700. At 400 nanometers, 2% will make a difference of about 8 nanometers. That would mean that you can visualize color from about 392 nanometers up to just below 700. If another person's mind is slightly bigger, only 2%, that would mean that you can add 2% there, which is 8. So he will have a spectral of 408. So the way we perceive colors, red, blue, green and all that, at perceived normal human beings, will fall in a specific range. We will basically all see red as the same red, blue as the same blue. A slight difference will totally change the color in the mind of that individual, because of the signal coming into your mind, with your mind having a faster processing speed, the lower you go on a spectrum, the faster your mind will process it to give you the perception that the spectrum is dragged out, which it's not. It's the same length, but because your mind is operating faster, in your mind it will stretch the frequency out to change the spectrum to a higher spectrum. So a red the color red will slightly change. If somebody is on the opposite side of that, the color red will become less, and the other side it will become more. This is very important to understand. Now it means from the one person, the one extreme to the other extreme is 4%. But people don't just differ with 2%. If you look at autism and you start studying certain parts of the brain, I'm not going to go into names, I'm not very good at names and it's not important. If you start looking at certain portions of the brains being abnormal in people who have autism, then this becomes very important. Then you will realize that they see colors differently. They hear sounds differently. Like where a dog's mind functions much faster, will hear your voice all dragged out, so you've got to give fast commands for the dog to hear it in a voice that is more susceptible to him. Remember, dogs and humans is not on this planet to interact. We interact, all animals, all species interact, but we're not meant to understand each other. That is why a dog is not meant to hear our voices in a way that we talk. So some people with autism, and I say that with the utmost respect, I'm not trying to make something out of autism, but this is a reality. Some will hear our voices like a dog hears our voices. Others will hear our voices like an elephant hears our voices. So by knowing this, one can start playing around with this. There's a lot of ways this can be researched, and there's actual ways that this can be rectified. The same as people would wear goggles or glasses or spectacles, called differently in different parts of the world. Like a person with short-sightedness or far-sightedness can wear corrected glasses, we will be able to devise or to construct devices that will be able to help autism and to gradually correct it in a way that you can improve your eyes. If you know the right methods, you can actually, in a way, get to improve autism. So, like we mentioned about autism now, if you look at all species across all ranges, with certain fish that's capable of looking into the ultraviolet spectrum, and certain species that can actually look into the infrared spectrum. Now, scientists doing studies, they would actually test the eyes of certain species and see what color of the spectrum, like ultraviolet, their eyes react to. So, when we perceive a certain species to be capable of visualizing ultraviolet, then that species, that's only a light source for him. He doesn't see it as ultraviolet. With a species with a smaller mind, with the mind working much faster, the ultraviolet is actually changed within a mind. So the way a specific species would perceive certain colors is totally different from how we would perceive it. Like a dog, for example. If you really want to see how a dog perceives the world, then you've got to study the perceived reality of a dog. There's ways of doing it. You've got to study the perceived way of the reality of a dog, how a dog perceives the conscious moment, compared to that of a human, then you will have to work out a percentage-wise. And then if you take any picture that a human can see, and you adjust it percentage-wise, then you will see the spectral of that vision will change. If you want to see, let's forget about animals, let's go back to humans again, being off with 2%. It's quite possible for us to see how somebody in a different different portion of the spectrum is viewing colors and the scene. By careful measurements and careful research and analysis, we can actually work out a percentage that another person is on the upper or the lower scale. If it's by 2%, you can take what you see and you can adjust every pixel in a picture with 2%, either up or down. And the way the colors will slightly change, you will get a slightly different picture. But in that way, you will actually see how the other person is perceiving the world. The same with voice. If you take a voice and you adjust it slightly, then you will actually perceive the way that other people perceive voices. But it's not that simple, because there's a catch. In the minds of certain people, time within a duration of 1 second becomes longer, slightly longer. Within a 1 second spectrum of a specific individual, for others time will become slightly slower. So the only way you can actually speed up or slow down your mind is by certain drugs. There's a lot of narcotics out there that can actually change the speed that our minds function at. There's a certain fish, for example. If you get that poison into your system, your whole anatomy totally slows down. Then people would be perceived to be dead, but in actual fact they are still alive. It's only the whole anatomy is moving at a very slow rate. So these people actually become zombies. There's some theories where they've actually found that people would be buried and then later revived where they were not dead. But I don't want to go into that. I'm just giving a very basic example of what drugs is capable of doing. The same with autism. By knowing what to look for, by knowing the realities of your conscious awareness, certain parts of the brain, by using specific drugs, certain parts can be sped up, other parts can be slowed down, as to bring the functioning of the brain to function like we would perceive a normal human perceiving time. That's all within our capabilities. But only if we realize and when we get to understand the realities of our lives, of how our minds work. For this moment, I think let's cut it for now. Thanks for watching. And once again, if you find any substance in my theory, if you like it, then please pass it on to as many people as you can, especially to psychologists, scientists and neurologists, so we can get this theory out there. The sooner we can make the world realize the realities of our existence, the sooner we'll be able to find a cure for autism that is certainly on the increase. The sooner we can help people that we believe to have disabilities. In the next episode, we will revisit the 6 seconds delay, and then in the next session I would like to go into the flicker fusion rate, where I will explain in more detail the difference between conscious awareness and the conscious moment. Thank you for watching.